Chris T, can you confirm that I'm up?
Yes.
All right. Welcome to the Central Arkansas Astronomical Society and Arkansas Space Grant Consortium's 2021 Observe the Moon event. I'm Bruce McMath. I'm filling in for Daryl Heath with the Space Grant Consortium, who's down with a non-COVID bug, unfortunately. Normally, this event would be held live and in person. Hopefully, we can do that next year. But tonight, we've got Danny Flippo with Cass, who will be imaging Saturn and Jupiter and their moons for us, and Chris Lastly, who will image our moon. That'll be the centerpiece of the program tonight, and that'll be tour guide by Rocky Togney, who is a Astronomical League Master Observer, one of the few in this state. Rounding out the team tonight is Chris Thody, who is monitoring the YouTube for comments. If you have any questions, he'll try to pass those along. First, though, we're going to start with Rocky using Stellarium, which is a free downloadable planetarium program, by the way, that you might consider taking a look at. Will show us where we're going to be looking in tonight's skies. Rocky, you ready?
Think so.
And while he's bringing up Stellarium, I want to point out that Chris has posted some links that you might find interesting to Rocky, and where you can find some of the images that Chris Lastly and Danny Flippo have put. They've beautiful, experienced astrophotographers, and then there's some other links as well in the comments you might check.
Okay, well, we're going to be basically viewing objects on the ecliptic tonight. So, and the ecliptic goes across the southern sky this time of year, and I'm going to start with Venus. We're not going to show Venus; it's too low, and we don't have anything on it. But it's still worth getting out there and seeing. You don't have to wait. Right now it's 7. You can see my little clock down in the corner. That's it. That tells you what date my Stellarium is on, which is a free software program that you can download. But anyway, Venus, I wanted to show you it to start with, and show you that it's also kind of a half moon right now, or gibbous moon. It's actually a waning gibbous planet right now, and it'll be viewable until about Christmas time, and it'll be getting smaller and smaller. But I think it'll be getting brighter and brighter too. So be sure you get out and look at Venus while it's up this year as the evening star. Then as we head up something else about Venus is if you get, and you can look at it, you might ought to look at it before it gets this low, about 7 o'clock or 7:15 tomorrow night. But you can see Antares is right below it. Antares is a first magnitude red star in Scorpius, which is laying on the horizon right now. So as we move up the ecliptic, we'll move through Sagittarius and into Capricorn. And Capricorn has Saturn and Jupiter both in it right now. And we'll be showing you these moons. This will be a reverse view, but here's basically not quite this good, but you'll be seeing the actual view in a little while of Saturn. And then we'll move on to Jupiter and see its 4 moons, which are all strung out to one side tonight. And then we'll go on to the moon, which, as you can see, is a gibbous moon, about 3 days from being full. And I kind of wanted to real quickly show you how we got to this point, so you kind of know how the moon I think Bruce may be talking about it a little bit more, but I'll show you on the screen. If we go back to the 6th, oh, I'm going the wrong way. Actually, the 7th or the 8th, when the moon came up in the sky, you can see it was a crescent moon then. And then every night it moves in the sky. Like that. So the next night it moved past Venus. And then it moves about a little less than 15 degrees every night till we get to the 16th tonight. And that's all I had. So Bruce is going to take it over now for a little while.
All right, let me have the screen and we'll go.
There you go.
Thank you. All right, so before we get up to the main feature, which is a tour of our moon, we thought it might be fun to talk a little bit about moons in general. Moons are also known as natural satellites, or objects that orbit planets, and in some cases asteroids, which frankly I didn't know until I was preparing for this. I'm sure Daryl would have. Earth has one moon, but there are more than 200 moons in the solar system that we know of, and of course many that we don't. Moons come in many shapes, sizes, and types. A few have atmospheres and even hidden oceans beneath their surfaces. It is possible that some harbor life even when their planets may not. If humanity manages to expand into the solar system, as some hope, moons with shallower gravity wells than Earth may become significant resources. Most planetary moons probably formed from the disk of gas and dust circling around the newly forming planet they currently orbit. But others may have been captured objects that formed elsewhere and fell into orbit around the larger world that they orbit today. All the major planets except Mercury and Venus have moons. Pluto and some other dwarf planets, as well as many asteroids, have small moons. Mars, as you can see on this chart, is a moon poor with just two tiny companions, too small to make themselves round, Phobos and Deimos. You can see how tiny they are compared to the other moons on this chart. Saturn and Jupiter have the most moons of any of the planets, with dozens orbiting each of the two giant planets, including five of the six largest moons in the solar system, our moon being one of that group, which can be seen, and all these can be seen in a backyard telescope, all these large planets. I say seen, full disclosure, as we will see, they just look like stars that move around the planets. But NASA has provided us with closer views of these interesting large moons, and we'll take a brief look at some of them. This is Titan, which is the second largest moon in the solar system. It's 50% larger than our moon and 80% more massive, about 4/10 the diameter of the Earth. It's the only known moon in the solar system with a dense atmosphere. Cassini probe showed hydrocarbon lakes around the poles, so you wouldn't want to light a match there, I suppose. It's composed of ice and rocky material and has some volcanic action, good prospects for life because of the amount of water that's involved. These are Jupiter's moons, large moons. Now, both of these, remember, planets have lots of moons. But Jupiter, Titan, Jupiter's moon, 4 Galilean moons, and Earth are the 6 largest. Jupiter has 53 named moons altogether, and there are at least 79 many of which are yet to be named. The ones of most historic interest are the first 4 moons discovered beyond Earth, the so-called Galilean satellites discovered by Galileo in 1610. Actually, he first saw it in December of 1609, but everybody says 1610 because that's when he got it published. The closest of these is Io, also known as Jupiter 1. 1 because it's the closest, the 4th largest moon, just larger than our moon, the moon, at 1,821 kilometers. This is a NASA Galileo spacecraft image. It has over 400 active volcanoes, and it's slightly larger than our moon. Io has the highest density of any moon and the lowest amount of water of any astronomical object in the solar system. Don't ask me how they know that. And it may be responsible for some of Jupiter's powerful radio spectrum. It actually orbits inside the magnetic sphere around Jupiter and becomes charged, and occasionally releases that in a radio signals. Now, a little note about the naming of these of Jupiter's moons. They were named by Simon Marius, who discovered these moons about the same time Galileo did, but he was slow in publishing it. So the early bird got the worm, Galileo gets the credit. And he worked for a long time on trying to come up with some names. And he says that Kepler is the one that suggested this, but he decided to name them after the Zeus's 4 lovers in Greek mythology. Now, you say Zeus, well, that's the Greek name for the Roman god Jupiter. So we could say Jupiter's 4 lovers in mythology. And that was, he did that, but it was largely ignored until the middle of the last century. Everybody just referred to them as Jupiter 1, 2, 3, and 4, like Galileo did. So here's Jupiter 2, or Europa, the 6th largest moon. It's a smoothest body in the solar system that we know of, because it's just covered with an ice. It has a thin oxygen atmosphere, and is another moon where it is possible, people theorize, could have life. Europa is Jupiter 3. It's the largest moon in the solar system, similar to Titan, but a little bit larger. Made up of equal parts rock and water, probably contains more water than Earth. Almost no atmosphere, and the oldest and most heavily cratered surface in the solar system. It has no sign of any kind of process that would erase its surface. So it's just similar to our own moon, shows almost its whole history on its face. And then finally, Callisto, the 3rd largest moon. And it's the most distant from Jupiter and outside its radiation belt, which may make it more interesting for humans to explore and perhaps exploit someday. So with that little introduction to these 5 large moons of Saturn and Jupiter, we will go to Danny, who will take us to Saturn. And I'll stop share.
Okay, Bruce, there's your live view of Saturn.
All right. And if y'all will look very carefully, the seeing is poor tonight. And what I mean by that is the atmosphere is really bubbling and boiling, which makes it hard to get sharp images. But if you look real carefully, you'll see something that's called a Cassini Division. Let me annotate it real quick. Right in there, right between the little division between the outermost set of rings and the innermost set of rings. The rings are actually full of divisions, when you get a NASA picture, you can see that the rings are full of divisions, but the biggest one, Cassini, was discovered in the 17th century, named after the discoverer. The rings themselves are a failed moon or moons. Either a moon's object that failed to coalesce into a moon at the time the planet was formed, or subsequently was torn apart by Saturn's gravity. And within the rings are many tiny moons or small moons that make these grooves, including the Cassini division. If you can shift this a little bit, we'll try to point out these moons. Danny?
I'm going to increase the exposure, and the planet's going to be really bright so we can see the moons.
So we can spot the moons. Maybe your gain.
Okay, how's that, Bruce?
All right. Now, have you flipped this on us?
I have changed the orientation to match your chart. So.
Yeah, you were trying to trick me, is what you were trying to do. So this is Titan. We showed Titan a minute ago. That's Titan, the large, one of the 6 largest moons in the solar system. If I can get over here to Ray, I can just make out Ray right there. And then on the other side, we had a little bit better vision earlier. It's coming in here. Here's Dione. If you can make that out. And then right there is Iapetus. And let me see if I can find Hyperion. We're talking about a little bitty moon when we get down to Hyperion right here, right there. So those are some of the moons that you can see of Saturn in a backyard telescope. You might notice some other dots. These are stars. Now, so a few notes here about it. Like I say, it doesn't look anything like the NASA picture, but you got to keep in mind that it's almost 1 billion miles away from us. And it is 1 billion miles from the sun, which is lighting. The only thing making it visible to us is the light it reflects from the sun. With that, let me see. We will go to Jupiter now. And while he's shifting to Jupiter, I want to point out that the Galilean moons have been pretty doggone important in the history of astronomy. First of all, they were the first moons discovered by anybody outside of our moon. And beyond that, and more significantly, when Galileo discovered them or observed them, he first thought they were stars. But then he started noticing that they moved, which was according to the existing theory of the universe at the time, the Ptolemaic theory shouldn't be happening. Under the Ptolemaic theory or view of the universe, all the stars were supposed to be fixed on rotating crystalline spheres and just moved with the sky. And so when he discovered, let me clear my marks here. Clear all my drawings so we won't get confused. So when he noticed they were moving, he started studying them and realized they were orbiting the planet, which was quite a revelation because it sort of blew the whole Ptolemaic theory, at which the core of which was the Earth was the center of everything, out of the water. He realized that Jupiter was just a planet like the Earth that had its own moons, and this brought the Copernicus theory into, which had already been published but widely rejected, into the mainstream. Later, the moons the motions and the orbits of the moons were used by Kepler to devise his third law of planetary motion. And then finally, the orbit of Io in particular, which orbits every 42 and a half hours around Jupiter, was used by Ole Romer in 1676 to reveal that light had a speed limit, that there was a speed limit to light. So the Galilean moons have quite a scientific history. At one time, they actually were trying to, Galileo theorized you could use it to determine your latitude, use it as a clock.
Longitude.
Your longitude, yeah. And which turned out not to be practical. It's hard to see them from the sea, which is where they needed to do that. So with that out of the way, we will turn to our moon, which is the, and if you'll unshare, Danny, I'll share again.
Have him brighten up the planet so they can see the moons.
Oh, yeah, we didn't point out the moons. I'm sorry, I'm so busy going through my notes. Yeah, give us the moons here.
All right, I think we've got Io
Okay.
and Europa there.
This is Io right here. Let me get my annotation out. Io right here. Well, apparently I didn't get my annotation. So, right there. Io. And this is Europa. Now remember, Io is actually the closest. Right here, it looks like Europa is, doesn't it? But the problem is that it ultimately has either already swung in or is swinging out. I don't know which, but it's an illusion. And then we need to go further out to the left on the screen to find Ganymede and Callisto.
Here comes Ganymede.
Yeah. We can see it up there in the corner. Right here. And we got one more a little further out. Way out.
Yeah, it's quite a ways out.
Might need to drop it some too.
Here it is.
There it is. Right there. Danny, let's go back to the planet real quick because I didn't, and try to get it back in view. I should have called people's attention to what we can see. And while you're doing that, I mentioned earlier that Danny and Chris have some beautiful images on the internet that you can see on those links that we provided in the comments. I don't know about Chris, but I know Danny has some fabulous images of the Jupiter and Saturn. And when you look at those, you'll say, well, why are they so much crisper? And I can see so much more detail in the images that he's posted online than here. And the reason is, well, first of all, seeing, as I say, is not too good. But the other is that the way they do this is they take lots of real short exposure images and then stack them up on a good night, and you can amazing how much detail you can get out. But anyway, you can see some of the dark bands every once in a while in here that you'll see even better in his pictures. So with that, let's move on to the subject of the star of the night, which is our moon. And I will try to share my screen again. Well, yeah. All right, just a few quick things about in the way of a lunar context. By the way, that looks like a painting on the right. That's a picture taken by another cast member, John Reed. It's really a beautiful, beautiful shot. So the moon has a lot of, it's not just an ornament in the sky. It's got a lot of practical impact on the Earth and on humanity. For one, it stabilizes the Earth's tilt. Without the moon, the Earth's tilt might be far more wild than it is as it is. Of course, it causes the tides, which probably has some biological and evolutionary significance, and it provides a nocturnal light, which it pulsates through all kinds of aspects of nature. I mean, just one example is sea turtles hatch at full moon, so they can find the sea. They see the moonlight reflecting off the sea at night, and they can make their way to the water before the birds get them. I mean, that's just one example. There's all kinds of aspects of biology that are keyed into the lunar cycle. The moon and us, the seasons, obviously, it tells us in our calendar. It's basically the fundamental of our calendar system. It's a monthly concept in our calendar system. Astronomy and science, like the Galilean moons, has played a large role in science, probably the most significant of which was the proof of Einstein's solar eclipse, which of course caused by the moon, or made possible by the moon, proved Einstein's theory of relativity. 1919? I should have made a note of that. And then, of course, in romance and literature, it's played a big role. It's the only natural satellite of any size in the inner solar system, the largest relative to its planet size in the solar system. It's 240,000 kilometers away, which is 1.125 light seconds. And it orbits every 27.32 days with a synodic period of 29.53, which is, as I say, where we get our months from. There's a lot of complexity in the relationship of the moon to the Earth and its orbit that you can get interested in. But a few things to note is it's tidally locked, which means that it turns on its axis at exactly or almost exactly the same rate at which it goes around the Earth, so that we always see the same side. And that's the reason you have a dark side. And that's the reason when you look at the moon, you see the same thing every full moon, basically. And another interesting happenstance is that its distance from the Earth has a relationship to its size to that of the sun, and the sun's distance to the Earth, with the result that it is almost the same size in the sky as the sun is, as seen, about a half a degree, as seen from the Earth, which makes the solar eclipse possible, which has been a big contributor to astronomy and to science, because we have been able to learn so much from solar eclipses. But we're losing it 1.5 inches a year. So eventually it gets further and further away, and that little factor will end. Some terminology, of course, probably everybody here is familiar with the first quarter and a waxing crescent, which means it's getting larger. The new moon is when the moon same side from the Earth as the sun is. Full moon is when it's opposite, so it's fully illuminated. You got waning gibbous, waxing gibbous, last quarter, new moon. These are just terms that most of you are probably familiar with. A few little things that I want to highlight before we start our live view tonight that'll help you get more out of it is the terminator. The terminator is the dark, is the line where the light of a partially illuminated moon meets the dark and the unilluminated side of the moon. And it's the most fun part of the moon to observe because it gives you the 3D effect of the shadows that are illustrated in this image. When the moon is waxing, getting larger, that's a sunrise on the moon. It takes the lunar day is 29 days long. So, and then when it's getting smaller, it's sunset. The main features that you can see with the naked eye are the Maria, the dark areas on the moon, the highlands, which are the pockmarked, highly impacted areas of the moon. And then you can see, with particularly the full moon, you can see the rayed craters, which are more recent craters that have put a lighter color soil, that ejected a lighter colored streaks of soil over the surface. Rocky, I'm sure, is going to talk more about all this. But because there's no atmosphere on the moon, no tectonic plates, anything to change the surface for the most part is nearly 4 billion years old. What you see there is almost, most of it has been there for nearly 4 billion years. And the Maria, the sea area, I wanted to point out here, the highlands on the left are very old. And the Maria is where lava has flowed and into the low-lying areas and covered up the original impact areas. That happened about, if I remember correct, Rocky, correct me if I'm wrong, about 3.8 billion years ago is when these lava flows occurred. And you can see how relatively smooth and unimpacted they are. So it just shows you how traumatic the first 500 million years of the moon's life were compared to what it's been since. As you go through these images, hopefully you'll be able to see, or wish our seeing was a little better. You'll see a lot of craters, obviously. Note that some of them have these peaks in the middle and some don't. That's just like if you throw a rock in the water and you make a ripple, sometimes the water will come back together in the middle and pop up. And finally, you can see like this rayed crater here, looking down the rays, you can see the impacts from debris that were cast out and then fell back to the moon, and then the white streaking that went along with that. You'll have these structures that are called rills that look like maybe water once flowed. Those are actually areas where you had lava tubes collapse. And then you'll have grabens or depressions like this, where little fault lines. So those are things to look for. And finally, some domes. You see the little domes in the upper left-hand corner there that look like little volcanoes. Curious features that may have to do with the magmatic rises of magma. So if you get it really interested in observing the moon, there are various programs you can get involved in and catalog your observations and earn a certificate from the Astronomical League for having observed them all. And Rocky, and Chris, let's take us to the moon.
Okay, you ready, Rocky?
Yep.
All right. All right.
Okay, what we're looking at is the northeastern edge of the moon. We're going to start northeast and go up that side of the moon. And Bruce was just saying that you see things better on the Terminator. Well, we're taking a tour of the moon, so we're going to look at some things that aren't on the Terminator, but that still show up. And one of them is this crater Endymion right here. It's a large lava-filled crater, wall plain they call it, 121 kilometers in diameter. And you can see it's not round, but if you were right on top of it, like some of the lunar orbiters have been, you'd see it's round. But since we're looking at it around it's so far around the edge of the moon, it looks foreshortened to us.
Rocky,
Something
can you
else,
annotate? Can you mark it with your annotation tool?
Yeah, can you see my mouse?
Can see a mouse. Is that where you want it to be?
Yeah, on this crater right here.
Upper right-hand corner. I don't think it's where you want it to be. What I'm seeing.
Yeah, that's my mouse.
Yeah, that's not.
You don't see my mouse?
No. Use your annotation tool if you would, so we can be sure.
Well, it was working a minute ago.
Well, you see, we're looking at Rocky's, I mean, at Chris's.
Yeah, but I did it on his.
I
Oh, you
can,
mean that
I can
annotation
attempt
too?
to annotate these, Rocky, from your notes. Oh, there you go. We see you now, or I see you.
Okay. Okay, let me try my mouse now. Can you see my mouse?
No, but I do see your pointer.
Okay. So this is Endymion right here that I was talking about. And it's normally closer to the edge right now, but something that we only see one side of the moon, but we actually see about 58 or 59% of the moon. And it rotates around. And this area right here is called Mare Humboldtian. And this is the first time I've ever seen it. And I've looked at the moon a lot, but I've just not caught it when the libration was right. So this is something you don't see all the time. Normally the edge of the moon is right in this area right here. But now the moon swept, we're looking around the edge of the moon even farther. So that's kind of neat. Endymion is a real old crater that was filled with lava. He was actually the son of Zeus, one of the sons of Zeus in ancient Greek mythology. And there's quite a lot on Endymion if you want to look it up. These two craters right here are Atlas and Hercules. And they're real nice if you get to observe them on the Terminator.
You're going to have to move your
Oh, that's right.
pointer. Two small black areas.
Yeah. Well, that's
Okay.
aggravating that we can't. I was writing text and everything. Okay, so now let's say we go to Mare Crisium. So
Okay.
go to your. So Mare Crisium is this large area here. There we go. And it's one of the distinctive mares, one of the first features you see on the moon. Like other large crater basins on our side of the moon, it filled with lava. There's very little lava that went to the other side of the moon, since the Earth was pulling the gravity of the Earth was pulling the lava toward us. So this side of the moon has got almost all the Maria or the lava-filled basins. It was named by Riccoli, who named most of the features on the moon. There's two that we're looking at tonight that were named by Langrenus. I'll talk about him a little bit more in a minute. Right here, still in the same picture. Let me see if I can get this arrow to move again. I ain't got this figured out yet. But anyway, yeah, there you go. This is Proclass, and it showed up on Bruce's map a minute ago, but it's the second brightest crater on the moon. It's a very new, recent crater, maybe only a couple or 300 million years old. But you can see the rays that extend from it. It's only 27 kilometers in diameter. And the ray system, some of these rays go out over 600 kilometers. So it had quite a ray system. The next object is in the same screen, Pallas Somni, and that's this area right above Proclass. And it's kind of the when Mare Serenitatis and Crisium, one of them was formed, it pushed up material here. And this is a neat, different place. I mean, I noticed it on and then had to look it up, but it's kind of a different color and different texture than any other place on the moon. So it's kind of a unique place. It's Pallas Somni, which means Marsh of Sleep. These things have real interesting names. They were named by Riccoli. They had other interesting names before that. But his are the ones that stuck. Okay, now let's move on up the moon some more, Chris. There you go. Right there. That's good. So this is the Sea of Fertility, the Mare Fecunditatis. And a couple of interesting things is these two craters right here is Messier A and Messier A. And they think that it, something hit and skipped and made the second crater.
Can you point it? Can you point to it?
Oh, yeah.
To the craters?
And
So that's
they're pretty neat. Huh?
a ricochet, huh?
Through a telescope. Another one is this real bright spot is one that was on Bruce's map of bright spots he had up a minute ago. And it's Langrenus right here, over here on the left of this. And Langrenus is a young crater, 133 kilometers in diameter on the edge of Mare Fecunditatis. And it's really distinctive at high sun. If you want to see it, it's so close to the edge. If you can't really see it when it on the terminator as a crescent moon very well, but you can see it right after full moon, day after full moon or something like that. If you want to look at it through a scope. Okay, now let's go to the right, over to Mare Nectaris.
And while they're doing that, we might point out that in a modest backyard telescope, you actually get a better image.
Better view than what we've got tonight. Yeah.
Than you were getting tonight. The imaging camera still needs a little bit of an exposure to make, and so the motion of the atmosphere blurs the image more than it would for the eye.
Okay, so this is so I can get my thing to move. Right here is Mare Nectaris, and it's the Sea of Nectar, a small lunar mare that actually is. The moon is divided into ages. The first age was like 4.53 billion years ago when it was created to 3.92 billion, and that was pre-Nectarian is what they call it. And then the next age is only 70 million years old. And that's when most of these basins and big areas were formed. And that was between about 70 million years, between 3.92 billion and 3.85 billion years ago. So this is Mare Nectaris that's named for. And some interesting, there's a real interesting crater, and I really can't make it out in the top part of this. I'm not going to try to, I don't think, but it's called Mare Fractatorius. Mare Fractatorius. I've actually sketched it before. It's really, really neat. It's a horseshoe crater. It's not showing up right now. Next thing is there's a nice string of craters over here. You can see one of them. Let me move my thing. Mare Theophilus, big crater right here. And then there's a couple more craters that don't show up very good above it. The craters, the little craters that are new show up real good. They're the white ones. And that's a nice string of craters, especially when they're near the terminator. I saw them the other night with a library telescope, which is only 4.5 inches, and they were pretty impressive. That little string of craters right there. The next thing we want to move to is just to the right, just off the screen, Chris. Yeah, that's good. I'm gonna try to get my thing to move now. But right in here is where Apollo 16 landed, was this area here. And it's the only landing, lunar landing. It was 21st of April, 1971. It was the only landing in the lunar highlands. And they gathered older material than any of the earlier missions. But this was Apollo 16, so that was next to the last mission. It's between craters Descartes and Lindsay, which I can't pick out right now. Okay, now let's go down to Mare Tranquillitatis, the Sea of Tranquility. Okay, so this is the Sea of Tranquility. It's a large, older lunar sea. Has numerous rills and craters in it. It has broken down edges, but it was filled with lava during the Embryon period, like between 3.8 billion and 3.2 billion years ago. And Apollo 11 site is up in the southwest corner, which is, let me see if I can point it out. And these two craters right here, Sabine and Ritter, help you locate it. It's just right about where I've got the pointer located. And that was the Apollo 11 site where man landed on the moon for the first time, 20th July 1969. It was chosen because of its flatness, lack of craters, and lack of boulders. And it's a good thing they chose that site because they missed the landing site by about 4 kilometers. So it's a good thing it was flat. But if you catch it right at sunrise with a good enough scope, they actually named 3 craters after Armstrong, Collins, and I don't remember the third one. Somebody else probably does. After the 3 astronauts that were there. Okay, let's move down to Mare Serenitatis now, the Sea of Serenity. It's kind of got a distinctive shape, kind of like a seashell or something like that, I've always thought. But my pointer is right for it. The Sea of and it's younger than Mare Tranquillitatis, and it has a lot better defined edges, especially through a telescope. But Apollo 17, they decided to land in this area. Let me get my thing to move. Down in this valley right here. This is the Taurus Littrow Valley, and it's very small. And this is Apollo 17, so this is after they'd already done 5 landings, but it had 6,000 foot sides to this valley, and they went down and landed in it. Most difficult landing site on the east side of Mare Serenitatis, and it was and Apollo 17 was the most productive of all flights and broke all records. How long they stayed on there, the amount of lunar material they brought back, and the amount of miles traveled in the lunar rover. They exceeded everything forever. It was the most productive mission. And just a neat note is, and some of you may know this, but Gene Cernan, who was on that, drew his daughter Tracy's initials in the lunar dust, and they'll be there for 1 billion years. So Tracy,
That's the one where they did the golf shot?
No, that was Apollo 14, I think. I may have that in here, but I think that was Apollo 14. But so Tracy Dawn Cernan is her initials are in the moon for eternity, pretty much. Okay, now Adonis, which is I think it's in the same area, down just a little bit. Yeah, right. Yeah, I saw it right here, right where my marker's pointing on the edge. There you go. So it doesn't show up very good, but it's actually a very interesting crater on the edge of Mare Serenitatis. Okay, now we go down to the bottom of the moon.
Before you go,
Fregosus.
well,
Go
never mind.
ahead.
Never mind. I was just wanting to know if is it the big ring or the little bright?
It was the big ring.
Yeah, the big ring here.
Yeah.
All right.
The little bright rings, when you're looking at the terminator, don't show up at all. They only show up at high sun, pretty much. There we go. I got it on it. That's Mare Fregosus right there. And that's the Sea of Cold, located on the north, and appropriately, it's located on the north, in the north regions of the moon. That's one. I had a hard time for a long time figuring out which way was north, south, east, and west on the moon. Well, north is toward the top of the moon if you're looking at it with binoculars, but I think Chris's view is upside down, so it's at the bottom of the moon tonight. And east is where is the first part of the moon that's illuminated. So when you got a crescent moon, that's the eastern, that's rising in the east. So that's the way you figure out east. Okay, Chris, I think go straight up to Mare Imbrium. You might have to go to the right a little bit.
It's amazing how much crisper everything looks as we get close to the terminator.
Yeah.
There's one
Okay,
of
so
those,
this is Mare Imbrium, this big black spot right here, and it's one of the, it's like the second or third largest basin. It's the second largest mare and the third largest basin on the moon. So it's you can tell it's pretty good size. Sea of Showers is what Imbrium is. The Sea of Showers, Mare Imbrium. It dominates the northwest quadrant of the moon, but there's lots of interesting features in it and around it. And three of them are these three craters right here you see in the upper left-hand corner. Archimedes, Autoclus, and Autolycus, and Aristillus. Three nice craters, and those are very nice through a scope. They also lead you to the Apollo 15, help you find the Apollo 15 site, which if you'll leave it right there, Chris, I'll point it out. It's near the edge, but see if I can get that marker to move. So the Apollo 15 site was right in this area where the marker is, and also in a valley. And Apollo 15 was 30th of July, 1971, and it was the first mission that had the lunar rover. And Bruce was showing you a reel a minute ago, which is a collapsed lava tube. So they just wondered what those things were. Well, they landed right next to one, and then with the rover, they were able to explore quite a bit of area, and so that's when they kind of figured out what those river-like areas were on the moon. It's a fascinating area through a scope when it's through a terminator, near the terminator. One of the higher mountains is right next to it here, Hadley Mons, just above where my pointer is. This dark area here is the Sea of Putrefaction, Sea of Marsh of Decay, Palus Putridinus. And that's what this dark area right here, and it's a little darker, as you can see, than some of the rest of it. Okay, now I think I can stay there and still see what I'm going to next, Chris. The Caucasus Mountains are down, or this mountain chain down below. There we go. This mountain chain right here, and that was pushed up when the Mare Imbrium hit. Of course, it pushed up a lot of material and it pushed it out that way. So let's go down now, Chris. or go up. I'm sorry. I said go down. I meant go up. Okay, there. So this mountain chain, and let me get my arrow back, is the Aponine Mountains. And they named that mountain chains on the moon after mountain chains on the earth. So you might recognize some of these names. This crater up at the upper right, just above it, is Eratosthenes, and it's a 3.2 billion year old crater that is the namesake of the Aristotelian age, which is one of the second youngest age, and it was from 3.2 to 1.1 billion years ago. And some of those have a lot of white in them, but most of them are. If you get good detail on them, you can see a lot of unmarred detail in them, like terraced walls and central peaks. I'm hoping that we can get to, yeah, you can actually see the terrace peak, the peak in this one. If you look at in the middle of it, it's getting, every once in a while you get good enough seeing to see it. Okay. Now, Chris, we go back to the left and up. Okay, let me get my bearings. I think down a little bit. The other down. Sorry. I wish I could draw down this
the network
way.
traffic up here is
Messing up.
yeah, we got a lot of lag all of a sudden. Comes and goes.
Yeah, I think this is where I'm wanting to go right here. Anyway, I'll go ahead. It's a sea of Mirabiform sea of vapors, and it's got a lot of dark spots in it. It's got a couple of craters. I saw them on Bruce's drawing a minute ago. They showed up good, and they actually had them labeled Menelaus and Manalus, and those are two craters that.
I'll be right back. We just crashed.
Unshare, and I'll throw something of the moon up, and while I'll throw a artificial moon up, a digital moon, unless you can get it back pretty quick.
I should be able to. It doesn't show that I'm sharing. Am I still sharing?
No.
Okay. Yeah, if you want to do that, I'll try to bring it back.
Okay,
up.
just tell me when.
Okay.
It's not sharing the right thing. I lost it.
Okay. Well, I'm back.
Okay, good.
I'll share this out real quick.
Okay, let's skip a couple and go on up to Tycho.
Okay, give me just 1 second. All right. Tycho, let's see. That was
back to the left, I think.
All right, hang on just a second, Rocky.
Is that it? That's Bullialdus. That's something on my list.
Okay. All right. So you want to go which direction?
Just a second. We'll go ahead and do that one while we're there, if
Okay.
that's it. I don't think that's it.
So you wanted to go back to the left?
Yeah. Should be rays coming out of it. Tycho.
Yeah.
Up to the top of them. I think you're back down around Serenitatis.
Here we go.
Yeah. Yeah, I see. I recognize that. Yeah, so this ray over on the right is coming from Tycho. There you go. There's Tycho. Oh.
Okay. All right. I'll stop moving.
So right above my marker is Tycho. And Tycho is one of the younger craters on the moon. It's only 108 million years old. Very sharply defined features if you catch it on the terminator. But when you're not on the terminator, like tonight, you saw that ray a minute ago. If Chris darkens his screen just a little bit, you can see the rays coming out of it. It's far enough from the terminator to see the rays. But these rays go halfway around the moon. Some of them are over 1,500 kilometers long, and it's really spectacular. When you get close to a full moon like this right now, you can go out and look at binoculars with it tonight and see Tycho really well and see the rays coming out of it.
You can see one line of craters and a ray going straight up from it.
Yeah, I see it right up here, right there. Yeah, and there's some that go all the way down to, actually some of it went through the Apollo 17 site, and that's one of the reasons they wanted to land there. They wanted to collect some dust from Tycho. Clavius is this big crater right up here. And it's one of the bigger craters on the moon. And it's actually one that you can see. It's the only crater you can see naked eye. When it's on the terminator, about halfway through it, it looks like a chunk's taken out of the moon. Because the inside of the crater is dark and the outside is bright, and it'll look like a notch taken out of the moon right there. So you can actually see it when it's naked eye. Now go down to the right.
Well, you can see the ray coming out now.
Yeah, there's some rays from Tycho. There's Tycho in the upper left. And if you stop right there, I don't have to move my thing. This is the crater Bullialdus, which is a young crater, Aristotelian age. That's and it's in Nubium, the Sea of Nectar. I don't think that's right, but anyway, I'm not going to correct it. It's a well-defined crater, about 3.2 billion years old. Nice terraced walls and a central peak. And since we're getting close to the terminator, you can actually make out some of that stuff. Let's go down to Copernicus now. We'll go through the Apollo 14 and 12 sites, but they're really hard to find. And with seeing like it is tonight, actually, hold on a second. I can show you both of them right here. This is the Apollo 12 site right here. Let me get. I get them backwards sometimes, but see these three craters right above my mark. One of them's almost hidden, and then two craters up above. So this is Fra Mauro. This is actually Apollo 14. And so it landed right about where my mark is. That was where Apollo 14 landed. the hills just outside of Fromoro. They wanted to, one of the main purposes was they wanted to find out get materials from Mare Imbrium. Usually they landed in sites that you could get multiple samples in those sites. This was before the lander, so they did the lunar rover, so they didn't get to travel as far. But this was the same site that was aborted when Apollo 13 aborted. The Apollo 13 was supposed to land here. And now I'm gonna Apollo 12. See if I can get my thing is right in this area right here. You can locate it using these two craters, which are Landsberg and Reinhold, two really nice craters. And then this little mountain chain, I forget the name of this mountain chain, but I know it's right above it. I've sketched it before. And Apollo 12 landed here, and the site was chosen for the same reason as the first site, because it's pretty level and very few craters and obstacles. But unlike Apollo 12 being 4 miles off, they nailed it. They wanted to land close enough to be able to walk over to the Surveyor 3, and they were, and they actually brought back parts from Surveyor 3. So they made a lot of improvements between Apollo 11 and Apollo 12 to be able to land that close to where they wanted to. So from then on, they chose a lot more difficult sites, like the two valleys that I showed you earlier. Okay, let's go down straight down, and we ought to find Copernicus. There's Copernicus, and it's one of the most spectacular craters on the moon. You can see all the it's what the Copernican age, which is the youngest age on the moon, is named for. And you can see even though it's fairly close to the terminator, you can see the brightness and the ejecta. Instead of rays, it's almost a blanket of material outside the crater. And this one, you can see the terracing on the inside through a little bit better seeing, and you could see the fall off on the outside, and you can see the central mountain peaks in it. But that's one of the most spectacular craters on the moon to look at through a scope. I was going to try to find, come straight over this way to the right a little bit, not very far. There. I was going to try to show you a dome, but I'm not sure we've got good enough seeing. This kind of looks like a dome right here. And there are a lot of domes in this area. If we had good enough seeing, I'm sure we'd see them. I think the one I wanted to show you, though, oh, hey, there it is right here. I see it. I'm sorry, I keep thinking that's a Malechia's pie. So I get this thing to move again.
Yeah.
See that little raised area right there? That's Malechia's pie. And with
like
a little
that,
bit better
Mr.
seeing, you could see a caldera in the top of it.
We might be able to see that if we move it over to the center. I think Copernicus
Okay.
is blowing us out. I'll try that.
I'm lost. There we go.
Yeah, I'll bring your pointer back to it.
But there's this is called the Malechia's dome field, and I've explored it with a 10-inch reflector before, and it was pretty fascinating with fairly good seeing. And you can see the calderas in the tops of a couple of those domes. There used to be a lot of people, and there still are, that check those domes to see if they're growing any. They get them near the terminator, and they measure the shadows of the dome and see if it's grown any, hoping that to detect volcanism on the moon, because that's what these are. These are shield volcanoes on the moon. Okay, now just one more object, and that's down in the straight down from Copernicus on the terminator, almost on the terminator, Sinus Iridium. That's actually coming in pretty good right there. Okay. So this horseshoe shape, or not horseshoe, but half moon shaped object is the Bay of Rainbows, Sinus Iridum. And it once was a large crater, but then when Imbrium flooded with lava, the lava broke down the outside walls of the crater and filled in on top of them. And some neat things about it's one of the prettiest spots on the moon. People enjoy it. They think it's one of the prettiest objects on the moon. These are the Jura Mountains behind it, and it has two promontoriums. The eastern one is Promontorium Laplace, and that's, there you go, right next to my pointer, sticking out. And the other one is Promontorium Heraclides, right there. But anyway, that's real nice in a small telescope. So Chris, that's all I had, unless we want to go up the terminator a little bit and see if we can find anything like we did last time, but I think we've about run out of time.
Okay, I'll let
Amazing how much better it is as you go along the terminator. It's usually this observe the moon night is when you have a terminator closer to first quarter, and it provides for better views. This is very close to full moon, and so much of it's just washed out.
Okay.
All right.
Any questions? Well, I guess we don't take questions tonight, do we, Bruce?
Well, if we have questions, they'll be in your chat and will have been passed along by Chris Thody.
No questions.
I'm not seeing any. So with that, if you'll let me have the screen back, we will wrap up. Share screen. Share. Well, and so here's some links that I wanted to share with everybody. Of course, the Central Arkansas Astronomical Society is cassastro.org on the internet, and one of these days we'll start having public star parties again at Pinnacle Mountain and Woolly Hollow State Parks. Hopefully this next year. We normally start in March, and I'm crossing my fingers that we will. I was talking to the superintendent of Woolly Hollow the other day, and he noticed if 80,000 people can gather in the football stadium, surely we can have a star party. Danny Flippo's images and Chris's images can be found on AstroBin and Flickr, respectively. I don't know why those two things exist, but what's different about them. But you can find these. You don't have to write this down. You can, if you can remember AstroBin and Flickr, you can just Google Danny Flippo and Chris Lashley on AstroBin and Flickr and find them. And they've got some great images that they're very accomplished astrophotographers. And then the Arkansas Natural Sky Association, I've got to get that ad in. darkskyarkansas.org is an environmental organization dedicated to the night sky and the nighttime environment. So you might visit there. And when you do, look up Observing 101, which is a course that Rocky and I offer twice a year on beginning sky watching. And then, of course, the Dark Sky Festival, which we had scheduled this year and had to postpone due to the pandemic, we will hold next October in 2022. And you can find that there. And then finally, the Eclipse, arkansaseclipse.info site has information on the annular eclipse that's going to occur in October of 2023 and the total eclipse that will occur in Arkansas in April of 2024. The first time in 100 years, a total eclipse has passed over Arkansas, and only the second time in the history of the state. The first one was sometime in the early 19th century. So thanks for joining us. That's it. Unless Chris has passed along some questions, we will sign off. Thanks for joining us. Good night. All right, let's see, chat. And okay, we're gone.